Hello, Algebra 2 students. Today we're going to be talking, as we move into Chapter 2, about relations and functions. A relation is really one of our basic concepts that we're going to be working with this year, and that is any set of input values. And a relation really has a lot of different possibilities. Most commonly referred to, a relation is merely a set of points. And you can see here I have a relation listed down where I have 1, 2, 3, 4, 5 sets of ordered pairs. And that's what a relation is a set of ordered pairs. A relation has two different parts, as you can see down here below, a domain and a range. The domain is the first part of each relation, so -3, +2, -2, 0, and +1. And the range is the y coordinate of each one. So what we're going to do is we're going to graph this relation just on our points as we review ordered pairs and things like that. So -3, +3 is our first point in blue. Our second point I'll put in purple. +2, +2, x and y. Our third point I'm going to put in red, -2, -2. Our fourth point I'm going to put in green, 0, 4. And our fifth point we'll put in black, +1, -2. As you can see, we've got our different points here. Now, a couple little review pieces. Let's review quadrants. The blue point, hopefully you can realize, is in quadrant 2. We'll put Q here for quadrant. The green point, the purple point is next, and that's in quadrant 1. The red point is in quadrant 3. The green point is on the y-axis. It is not on a quadrant. And lastly, the black point is in quadrant 4. Remember, our quadrants are in the shape of a C from 1, 2, 3, and 4. So hopefully that helps a little bit reviewing your quadrants and understanding how we graph a relation. Next, we're going to talk about domain and range. And in Algebra 1, you may have remembered some other names for domain. Other names for domain include X. They include input. They include the word abscissa, and they include the word ordinate. Excuse me, not ordinate. So X, input, and abscissa. And the range could be considered as the words Y, output, or ordinate. And as you look at these words, just a reminder that helps you remember how they pair up. They're all alphabetical. Domain comes before range, X comes before Y, input before output, and abscissa before ordinate. And those are a number of different names for domain and range. Now, there is one final name for range that is often a little bit unique and does not have a pair that goes with it, and that is f of x. And you'll notice what I said there was not f parentheses x, but I said f of x. It's the function f evaluated at x. So just a little bit of verbiage there to help you realize some different names for the word range. Next, down here in example 2, we have an ordered pair, and we're going to write down the different points. And we have a number of points. We have 5 points here. I'm going to label them 1, 2, 3, 4, 5 in no particular order, but let's just start that way we can refer to them. Point number 1 is -4, +4. Point number 2 is -2, +4. Point number 3 is +3, +2. Point number 4 is +2, -4. And point number 5 is -3, -2. To identify the domain, all we need to identify are the x values for each one. So we have -4. I'm going to underline that. We have -2. We have +3. We have +2. And we have -3. Those are my values of the domain. Ideally, we'd want to write those in ascending order from lowest to highest. So the -4, then the -3, then -2, then 2, then 3. The range is the values for my value of y. So let's look at my values for y. And I'm going to start with the lowest one down here at point number 4, and that's the value -4. My value here at point number 5 is -2. Going up on the screen, my next value is at +2 for point 3. And then going all the way up to +4, we have our final value of 4. Now I need to make a note here that we do not write values if they repeat twice. If they repeat. Okay, so just a little sidebar there as we're working through. All right, well, let's kind of move on here down to example 3. Example 3 uses the ideas of mapping, and it's a way that we can illustrate a situation through drawing some arrows and kind of grouping things in domain and range. So I'm going to write down my values for my domain here in the left-hand green box. My domain is -1, +1, and that's it. My range, on the other hand, is 7 and 3, and that's my range because I've covered all of them, even though I have 4 points. Now we're going to do the mapping process. I'm going to underline this one in red, and so -1 has an input of -1 and an output of 7. I'm going to underline this one in purple. 1 goes to +3. And underline this third one in blue. 1 also goes to +7. And lastly, I'm going to underline this one in green. -1 goes down to +3. So we've mapped these using arrows saying, hey, this is our inputs, these are our outputs. But notice in our domain and our range, we've only listed each point once, even though they both repeated twice. That's how you do mapping. The next part is probably one of the most important parts we're going to talk about today, which is the definition of a function. And you're going to need to memorize this, which is just going to be very simple. A function is simply a relation in which each element in the domain is paired with exactly one element in the range. One way people can think about this is through an idea of the birthday example. And a birthday, if you think about it, one person can have one birthday, and you can only have one birthday. So if you have one person, for every person, they have exactly one birthday. No person has 2 birthdays, but you can have multiple people having the same birthday. And that's a good example of what a function is. And we're going to talk more about that later. So, as we look down here at just some static numbers, we have a domain and a range where we have the number -3 going to 2 different y values. Well, let's think about this. Does the number -3 pair with one and exactly one number? No, it does not. Okay, the -3 pairs with 2 numbers, 4 and 5. So that is not a function. It doesn't matter that the -3 and the 2 both go to 5. Ideally, they could both have, quote, quote, the same birthday. Over here, on the second part, we have the domain and the range where each number, 2, 4, and 3, are each going to one and only one element in the range. And so that is a function. Notice for every value of the domain, it is paired with one and only one value in the range, even though the numbers 2 and the numbers 3 go to the number -2. For example, they each have the same birthday, and that's perfectly fine and perfectly acceptable. So the birthday method is a great way to keep that straight in your mind. Let's move down and talk about another way to compare if something is a function or not. We use an idea called the vertical line test. The vertical line test merely says if you draw a vertical line on the graph, then the relation is not a function, and it will clearly show you if a value has 2 points that are the same when we draw a vertical line. So let's look at example 5. If we were to draw a vertical line in example 5 in any number of places through the graph, we would find that at no place does the line go through 2 points. And so this is a function. Let's look at this example to the right. This is an absolute value graph, just to let you know. This is the graph of y equals the absolute value, x equals the absolute value of y. And if we were to draw a vertical line through here, we would see very clearly at many spots it goes through 2 points. And so this is not a function. Numerically, you could do that by saying, if you look right there and right there, there's 2 points, 2 comma positive 2 and 2 comma negative 2, that both have inputs, but they have 2 different outputs. Let's look down here at our next one. I'm going to draw a vertical line through my first spot at negative 2, and instantly I see that both at negative 2 and at positive 4, our lines go through 2 different points. And so this one is not a function. Our last one is the graph of y equals negative x cubed. We're going to deal with that in the spring. If we draw vertical lines through here, you'll see that this is a function. So yes, it is a function. And the vertical line test is really one of the best ways graphically to show if something is a function or is not a function. And as we move forward, as we look into calculus and down the road, be able to determine this by visually quickly inferring whether or not something is or is not with a vertical line test is a great way to determine if something is a function or not. Moving down, let's talk about function notation. When you see the function f parentheses x, very simply it's read as f of x. Realize this could be written g parentheses x, which would be read g of x. What does it mean? It means for the value of x, evaluate it. Whoops, sorry about that. We're going to evaluate into the function f or g or whatever function they tell us to. So in these next couple examples, I'm using the variable f just for the function letter. So here we have the first function, the opposite of x squared plus 1. I want you to remember this is the opposite of x squared plus 1. You need to make sure you square the x, then take the opposite of it. So when we plug in the number 2, the opposite of 2 squared plus 1 will be negative 4 plus 1, which is negative 3. So f of 2 is negative 3. When we plug in for f of 4, we have the opposite of 4 squared plus 1, which is negative 16 plus 1, which is negative 15. So f of 4 is negative 15. As we look at the value for b, we have f equals the absolute value of 3x. So the absolute value of 3 times 2 is the absolute value of 6, which is 6. So f of 2, in this case, is 6. Over here, we have f of 4, so 3 times 4, which is 12, and the absolute value of 12 is 12. Obviously, we didn't have any negative numbers that came into play here, but had we had them, the absolute value would have made an impact on the problem. Our last problem involves a very unique graph that we'll look at in the spring, where we have the x in the denominator, which allows us to have something called asymptotes. But let's try to plug in our values here. 9 divided by 1 minus 2 equals 9 over negative 1, which equals negative 9. So f of 2 equals negative 9. Over here we have 9 over 1 minus 4, which is 9 over negative 3, which is negative 3. So f of 4 equals negative 3. Now, I realize I've written all these with function notation, but I want to go back and help you show that each one of these could be written as a point. So written as a point, we could write this first one as the point 2, negative 3. Or over here, 4, comma, negative 15. Down here on B, this could be written as 2, comma, 6. Or over here to the right as 4, comma, 12. And then down here at the bottom, this could have been written as 2, comma, negative 9, input and output, and 4, comma negative 3. Let's go back and kind of take a look at our total part today and review very quickly before we wrap up. First of all, a relation is a set of input and output values. It's usually could be listed as a table. It could be listed as a graph. Each of the points has an input and an output, an x and a y, an abscissa and an ordinate. The y value also could be talked about as f of x. We can graph ordered pairs of a relation on a graph. Remember, a relation can be any set of points. It doesn't matter. Realize that we write the domain and the range. We do not repeat values. And then as we're making a mapping diagram, we merely label at the top. It is important to label what the domain is and what the range is. And then we list the domains on the left, the ranges on the right with arrows going back and forth. A function, very simply, is a relation in which each element is paired with exactly one element in the range. Remembering the idea of having a birthday, and many people can have one birthday, that's acceptable, but one person cannot have many birthdays. And then the vertical line test is a great way to show whether or not something is or is not a function by drawing a vertical line through. And then lastly, trying to determine what is a function when you plug in values to evaluate, and realizing that our resulting parts, the outputs, could also be written as ordered pairs, and then we could consider things going from there. Our homework tonight is on section 2.1 on page 59, 1 through 11 odd, 12, 13, 16 through 21, 25, 27, 62, and 63. On 62 and 63, they're going to provide us some standardized multiple choice practice like we saw in what's coming up on our ACTs.